Hello, and welcome to this module on Object Storage Service. After completing this lesson, you should be able to describe the key concepts, as well as use cases and storage tiers of the OCI Object Storage Service. You will be able to manage buckets and objects, and you should understand the features of both multi-part uploads and the Amazon S3 Compatibility API. Let's go ahead and get started. If we take a look at our storage matrix here that we looked at earlier as well, we'll find that object storage is at the highest durability end of our measurement spectrum. Object storage is internet scale, high performance, highly durable storage. It's ideal for storing unlimited amounts of unstructured data in the cloud. Now, the Oracle Cloud Infrastructure Object Storage Service is an internet scale, high performance, durable storage platform that offers reliable and cost-effective data durability. The Object Storage Service can store near unlimited amounts of unstructured data of any content type, like images, log files, archival backups, media files, etc. Data in the Object Storage Service is managed as an object, not like files or blocks. It's not managed using any typical storage protocol, but rather utilizing HTTP methods such as get, put, post, and delete. With object storage, we can safely and securely store or retrieve data directly from the internet, or we can do it from within our cloud platform using multiple management interfaces that allow us to easily interact and manage storage at scale. Object storage is a regional service, so that means it's not tied to a specific compute instance or a specific availability domain. When we provision a bucket in object storage, that resource is tied to the entire region, and any data placed in that object storage bucket is automatically replicated to multiple availability domains behind the scenes to ensure the highest possible durability of the data. Some common object storage scenarios include content repository for storing highly available and durable content for accessing things like data, images, logs, etc. It's also used as an archive or a backup solution. It allows us to store a large amount of data that we might need to retain for long periods of time, whereby we may not be accessing that data readily, but we can store it for a long period of time at a low cost. We might also be storing log data for analysis or troubleshooting, or large data sets such as pharmaceutical trials, genomic sequencing data, or Internet of Things sensor data, IoT sensor data. Another use case is as a big data Hadoop file system. So typically if we spin up a Hadoop cluster, that each node in the cluster would include large amounts of local storage, which would then be configured to act as a Hadoop file system or a clustered file system. When a Hadoop job is executed, it utilizes distributed components across that Hadoop file system to be able to evaluate, aggregate, and manipulate that data. Rather than relying on local storage within the compute nodes of our HDFS, of our Hadoop cluster, we could simply store all of that raw unstructured data in the object storage service and utilize the Hadoop connector to evaluate or attach to that data directly from our big data tool sets like Apache Spark or MapReduce. Now, the resources in object storage include the object, which is the data. So regardless of content type, it's stored as an object, and that object also includes metadata about the object or the file itself. The bucket is a logical container created by the user and can contain an unlimited number of objects. The bucket itself is associated with a single compartment, which in turn defines policies that indicate what actions a user can perform on that bucket itself. The namespace is a logical entity that gets created with a tenant and spans all compartments in a tenant. So within a single namespace, buckets have to be unique, but they can be repeated across namespaces. So if a customer has multiple tenancies, each tenancy could have the bucket name or a bucket name that matches a bucket name in a different tenancy. So as long as the combination of namespace and bucket name are unique, there's no issues, there's no contention. Buckets themselves live in a single compartment at a time, as specified. However, the policies allow us to define access from other compartments to the resources in that particular bucket. Object storage has a strong consistency mode. This means that when there is a read request made, you are guaranteed a consistent, most recent copy of the data that has been completely written to the system. We have a high-performance network where the lookups for data are fast and consistent. To provide durability, the object storage service copies object data throughout a region across multiple availability domains. Data integrity is maintained with active scrubbing functions. Typically, there are 3 to 6 copies of a given object in the service. That means that we can easily sustain the failure of a storage device, of a network link, or potentially even a catastrophic failure impacting an entire availability domain without compromising the durability of the customer's data. The data on the object store is always encrypted. So Oracle is going to manage the keys, but every time a customer loads data into an object storage bucket, it's automatically encrypted using AES 256-bit encryption before the data is written to disk within the storage construct. Now within object storage, we have 2 different storage tiers. There's the standard storage tier, also referred to as hot storage, for when we need fast, immediate, and frequent access. The object storage service always serves the most recent copy of the data when a retrieval request is placed against the API. In this instance, data retrieval is near instantaneous, and we can begin to download that object immediately. Important thing to point out, standard buckets cannot be modified or altered to archive, and vice versa. So if we needed an archive bucket, we would create that. If we then needed a standard storage tier bucket, we would have to create that as a new bucket. Now, archival storage or cold storage is great for data that's rarely accessed, but must be retained for a very long period of time. So think regulatory compliance. In certain circumstances, we might have to retain data for 7 years, 15 years, 20 years, or even indefinitely, even if the likelihood of that data being retrieved is very, very low. So in order to maintain the lowest possible cost for this storage, customers can create an archive storage bucket and place the data in that location. Now, in order to retrieve this content, there is about a 4-hour delay, and what we call the time to first byte. So when a restore operation is submitted, it does take about 4 hours for the system to go and retrieve that content and begin to download it back to a standard storage tier bucket. Once restored, that object can then be retrieved from the standard storage tier bucket. In order to create a bucket, we would navigate to the object storage console. We would click Create Bucket, simply give the bucket a name, and select the storage tier type, either standard or archive. When it comes time to upload an object, we could use the management console to upload objects one by one. So we would simply click the bucket to go into the details of the bucket. We would click Upload Object, and then we could either browse for the object or simply drag and drop an object from an existing Explorer window onto the web UI, and then click the Upload Object bucket. Now, it's important to keep in mind that the management console is really not intended for large-scale object storage operations. Object storage is a programmatic function. Whether we're using a third-party tool, a third-party backup solution, or simply writing our own custom code that creates a front-end interface and stores that data on the object storage system in the back end. Most often, customers that are using object storage are either utilizing the command line interface or a custom software development kit like Python or Node to create applications that allow them to interact more easily with the object storage service. If we're looking to do bulk uploads and downloads, that feature is readily available within the OCI command line interface. Within the console, again, we upload one object at a time. Once we store content in our object storage bucket, we have a couple of ways to gain access or share access with that content. By default, the bucket is going to be private. That means the only way to access content in the bucket is to authenticate using an IAM entity or IAM principal, which we discussed earlier. I either have to have an IAM user, or I have to be connecting from a compute resource with an IAM instance principal with the associated permissions. Now, if I'm looking to share content with users outside of my OCI tenancy, the easiest way to do that is to create a pre-authenticated request. Now, a pre-authenticated request is typically done at the object level. So I would select the object, I would select Create Pre-Authenticated Request, and I would specify a name for that request. I also get to specify when that request expires. So when I create this request, Oracle automatically generates a secure token, an authentication token for this request. It embeds it in a custom URL that I can then copy and share with my users or my partners. At any point in time, I can easily revoke that pre-authenticated request, rendering that authentication token null and void. So I can immediately remove access or revoke access to that content by simply deleting the request. Another option to make our content readily available would be to change the visibility of our bucket from private to public. So a public bucket is generally accessible by anyone using standard HTTP verbs like put, post, and get without any authentication mechanism. So if I were storing non-sensitive data, perhaps open source community content in an object storage bucket, and I wanted to share this with any number of people around the world, I would simply change the visibility of that bucket, and I would share the link to that bucket out to anyone who is interested in accessing my content. Stay tuned after the module. We'll do a brief demo of what a pre-authenticated request and a public bucket might look like in use. Since a bucket can have unlimited number of objects, one common ask is how to upload such huge chunks of data. For the object storage service offers a multi-part upload feature to efficiently upload large files. You can segment your file into smaller portions and then upload these parts in parallel. Object storage supports up to 10,000 parts per file, and a part can be as small as 10 megabytes. Using multi-part upload not only significantly reduces the upload time, but also minimizes the impact of network failure. In the event of a network blip or a brief outage, if one or more parts fail to upload, we can simply retry those individual parts versus having to attempt to re-upload the entire object. This feature is currently offered via the OCI API and the Software Development Kit. It's also available in the OCI command line interface. It's important to note that the maximum size of a single object cannot exceed 10 TB bytes, and the object parts can be no larger than 50 GB in size. So if we needed to store a single 10 TB byte object, we would simply deconstruct it into 50 GB or smaller parts and perform a multi-part upload. Now, I won't cover this specifically, but if you're curious, feel free to Google TB byte versus terabyte. There is a slight variance in the math used to calculate the total size. That's the variance between TB versus mega versus tera, or MIBI versus mega. Now, one of the new features of the object storage service is the Amazon S3 Compatibility API. Customers can now use this API in addition to the OCI native API to manage OCI object storage. That allows any tool with applications that integrate into Amazon S3 to migrate over to the OCI platform without having to rip and replace APIs. This also helps promote an open cloud platform where customers' data can be supported on both AWS or OCI. So trying to avoid lock-in, that's really the goal here. There are a few differences that we've highlighted on the slide here that we should consider within the design process. Namely, AWS does not have the concept of compartments. So in the case where we're using the S3 Compatibility API, the buckets are automatically created in the root compartment of the OCI tenancy. In terms of the global bucket namespace, object storage doesn't use a global bucket namespace. It only uses a tenancy-specific namespace. So bucket names must be unique within the context of a namespace, but they can be repeated across namespaces. Once again, on OCI object storage, all data is automatically encrypted at rest by default, and this is not something that can be turned on or off. If you're working directly with AWS S3, server-side encryption is not enabled by default, and it must be actioned on each object as it's uploaded to an S3 bucket. Now, when it comes to pricing, object storage, again, is pretty straightforward. It's a pay-as-you-go model based on the amount of storage that's actually consumed. So the rate for standard tier or hot storage is going to be 2.55 cents per gig per month. And for archival storage tier, it's going to be 0.26 cents per gigabyte per month. Now again, it's prorated over the course of the month, and it's only in actually consumed space. There's no need to pre-allocate any amount of space within the object storage service. Now the other factor to consider here is the number of storage requests. So every get, put, post, delete counts as a storage request. So every 10,000 requests would be billed at 3.4 cents per month. This is significantly lower than AWS, for example, who charges about 3.5 cents per 1,000 requests. So nearly 10 times less expensive per request. For customers who are using object storage as a very high velocity content delivery mechanism, those requests can add up dramatically, especially when the customer is paying per 1,000 requests versus per 10,000 requests. So in summary, we've learned that the OCI Object Storage is an internet-scale, high-performance storage platform for storing an unlimited amount of unstructured data. It supports strong consistency model and offers the highest level of durability, often storing between 3 and 6 copies of every single object placed in a bucket by the customer. Object storage supports both standard tier for fast, immediate access and archive tier for seldom or rarely accessed data. It also supports pre-authenticated requests and multi-part uploads. Now let's transition and take a look at a quick object storage demo. Starting in my object storage console here, I'm going to go ahead and create a new bucket. This bucket will be called training. I'll just go ahead and leave the standard storage tier in place, and I will create the bucket. Within a matter of seconds, I have my training bucket, and I can navigate into that bucket. Once I've navigated into my bucket, let's go ahead and upload a couple of objects. Remember, through the console, we upload one object at a time. So I'll browse. I'm going to pick Tux. We'll open that. And we can change the object name if we so choose, or just leave it as the same as the file name. I'll go ahead and upload object, and that object appears in my bucket. Let's go ahead and upload a second object. Once again, we'll browse, and I'm going to select another image here. We'll open, we'll upload, and now we have a couple of objects. From here, I can view the details of the object. This is going to show me the size of the object, the content type, the MD5 hash, which is used for that consistency checksum, and other information. So this might be considered, or this would be considered the metadata that's stored in conjunction with the actual file. If I choose to download that, I simply click the download link, and it would go and do an HTTP GET of that particular object. Now the other option here is to select the URL path, and we'll use this in here in just a few minutes. So the other options I have are to edit, and this simply gives me the ability to change the object name and or prefix. So one example would be to create a prefix. Let's call this images. We'll call this image.jpg. Now as I've added a prefix, this gives me the ability to filter the contents within my object storage bucket. So if I'm looking for a prefix of images, that would automatically show only the contents with the corresponding prefix. So again, if we're interacting with these resources through the console, utilizing prefixes makes it much easier to sort through a very large set or large quantity of objects. Now, let's try to actually access that resource. So I'm going to open a new browser tab. I'm going to paste in that link. And it's going to tell me right here that either the bucket doesn't exist or you're not authorized to access it. That's because the bucket is private and I have not passed any authentication credentials. If we dissect the link, the first part of the URL here, objectstorage.usphoenix-1.oraclecloud.com, is the API endpoint. The next segment, the /n, followed by this, is my namespace. That's my tenancy ID. Followed by /b, which is my bucket name, followed by o, which is my object. So as we noticed here, there's no way we can't access this object because we're not authorized to do so. One quick fix is to simply update the visibility, change it to public, and save. Within a matter of seconds, I could come back to this tab and refresh. Oops. We forgot to add our prefix. And now I can access that object. Now, let's go ahead and set this back to private. Again, it's a very easy single click, save, come back over, refresh, and we broke it again. Hooray! All right, so round 2. I need to share just this one object with my customers/users. So for that, I would create a pre-authenticated request. Let's call this one-time use. And this request applies to the specific object that I selected below. Now I can permit reads only, I can permit writes, or I can permit reads and writes. Now why would I want to allow writes? Well, if I were making this private bucket available for a customer to upload an object on a one-time basis, I could permit writes, and utilizing this pre-authenticated request, that customer could upload or post a new version of the object to my object storage bucket. For this demo, we're just going to permit reads on the object. The last thing we'll do here is specify the expiration date. So we'll have it expire Saturday at 1:18 a.m. GMT, and we'll create the request. Now, if we dissect this URL one more time, we'll notice we have the API endpoint, but we have a new entry into the URL string, the /p, which is the pre-authenticated token. And this is the token that is created dynamically when I generate the pre-authenticated request, and it's fully managed by Oracle. So at any point in time, I can simply delete this token to revoke access to this particular object. So let's go ahead and copy. We'll return to our testing tab here, and we'll go ahead and paste that new URL in, the URL that includes that token. We'll go ahead and hit enter, and it's going to authenticate and retrieve that object for me. Now, let's say we accidentally publish this link to a public location that was not intended, and we suddenly notice that thousands of people are downloading this content, and we need to turn this off. We simply return to our OCI Management Console, navigate to the Pre-Authenticated Requests section, and delete. That token is discarded, the authentication request is rendered invalid, and if I come back here and refresh, you'll notice that I can no longer access the resource. This gives customers great and easy control over managing access to their object storage resources. That's it. We'll see you back here in a few for the next module.